Okay, let's get started on the review for rational functions test. On our first problem, we need to describe the transformations as well as graphing it. I'll make sure you're doing both parts. So our transformation of function looks like f of x equals a divided by x minus h plus k. So looking at the example we have, a is 2. That tells us it has a stretch of 2. We have an h value of 1. H is our horizontal, so 1 it means to the right, 1. And we have a positive 2, which is k. That means we've gone up 2. These two tell us what our vertical and horizontal asymptotes are. So let's go ahead and draw those in. We moved right 1. We always draw our asymptotes as a dashed line, so x equals 1. And we went up 2. The equation of this line is going to be y equals 2. All right. Now we also have a stretch. I'm going to zoom in a little bit so you can see what's going on. What the stretch tells us is that we look at where our asymptotes intersect. We'll go to the right or the left, 1, and then go up as many as our stretch. So instead of going up 1, we're going up 2 since there's a stretch of 2. Likewise, we'll go to the left and go down 2. We also then will go up 1 and to the right 2, and down 1 and to the left 2. You can think of these as pegs that you're stretching a rubber band past. It starts way out here, comes in, and goes back out. Again, the function we always show is a solid line. Likewise, in the bottom left, it comes in close to the asymptote, goes through those 2 points, and continues out, getting closer and closer to our vertical asymptote. Okay, problem 2, we are given our asymptotes, and we're asked to find the equation of the line and describe what happens. So we've got a horizontal asymptote of y equals -1. So the horizontal one tells us what the k value is. So k is -1. A vertical asymptote of 3 tells us h equals 3. So when we plug these in, we're going to have y equals, let's check for our stretch, no vertical stretch, so we have a 1 on top, x minus 3 minus 1. The transformations that happened, at x equal to 3, that moved it right 3, and the -1 for k moved it down 1. Okay, problem 3. A rational function has a horizontal shift of 4 to the right and a vertical shift up 3 and a stretch. Okay, so again, our equation, we deal with the stretch first. So we've got a 2, and it's moved to the right. So that will be x minus 4. Our vertical shift is up, so let's add 3. Our horizontal asymptote comes from the value from our vertical shift, which was 3. So it will be y equals 3. The vertical asymptote comes from our horizontal value. So x equals 4. Let's see if we can scoot up here so you can see the next problem. We're given a rational function. Let's scoot in a little closer on this. And we need to find our zeros and y-intercepts. So our y-intercepts are when x equals 0. So if we were to go through here, anything that has an x in it, we're going to be putting in a 0, which makes that term disappear. So it would be 0 squared minus 0 minus 15, 0 minus 7 times 0 plus 10. So our y-intercept is going to be 0, and what's left over? So -15 divided by 10. We don't normally leave our problems like that. So I would rewrite that as 0, -3 divided by 2. You could also put that as -1.5, which is also correct. I would take either one of these as an answer. To find our x-intercepts, we have to factor the problem and cancel. So let's see on the top, we're looking for things that multiply to give us negative 15, but add to give us 2. So x minus 5 and x plus 3 gives us that result. On the bottom, we need to multiply to give positive 10, but add to give negative 7. That means both of them will be negative, so x minus 2 and x minus 5. As two negatives multiplied to give me the positive. I would cancel the x minus 5 from the numerator and denominator, and I'm left with x plus 3 on the top. To find the x-intercept, I'm going to take what's left on the top, x plus 3, and set it equal to 0, and solve. X equals negative 3. So for my x-intercept, the x value is negative 3, and the y value is 0.